All right, it's all you, Aaron.
All right. Can everybody hear me okay and see my screen? I will say, if you turn on video, I will take into account your facial expressions in giving this talk, and if you do not, I will not. So take that as it were. The topic that I came today to talk about is a topic that I call Theseus IDs. I've been working with the DID groups for a while, and there are over 100 specifications that have all been proposed as different methods of accomplishing a distributed identifier. Some of them are very distributed and wild, just pick a key. And some of them are very centralized. Go to this specific website and ask for a handle, and they will assign you one. Something like did web really ties you to a specific name. And I'm making my proposal that I think the class of IDs that we want to use for systems as you build them in the future is Theseus IDs. So this is my pitch for people who are going to be building the blockchains of the future, that when you think about identity, you want to use some kind of Theseus ID. I have the link on the page for the DID spec registries that will allow you to go through and see lots of different people and how they solved the problem of trying to build a decentralized identifier. So I'm Aaron David Goldman. I have a long history of working with distributed systems. I did a PhD at Georgia Tech in information security, largely about trying to figure out, can we build systems where the trust is more based on who you are and less on the CA system? It just bugged me as a student that when I got my domain name, I bought my domain name from a registrar, and then I had to go to the CA and prove to them that I bought the domain name. And I was like, this whole CA system doesn't make sense to me. I think we can do better ways of getting identity. And some of that is what led to the ideas in this talk. So the first thing that I want to hammer in, if you take nothing else away from this talk, is don't use keys as identifiers. There are lots of people who had Bitcoin wallets. And what is the identifier of a Bitcoin wallet? Oh, it's your public key. Now, the advantage of having that public key is it's relatively easy to do the math and be like, hey, you signed a thing, I checked it with the public key, you're that person. It's a very tidy answer. But if you lose your keys, you no longer have any Bitcoin. So we want to have IDs that have properties that we don't get by just using a key as an identifier. Okay, so we're not going to use keys. So the problem is we have to use keys. The way we on the internet identify anybody with everything, every SSL connection that you use, every time you SSH into a computer, the way we prove identity online is we encrypt our connections and we check that that connection has been signed by the appropriate person. So moral one, don't use keys. Moral two, we have to use keys. Keys are the only way that we can identify people online. So how do we build an identity when we have this contradiction? And that brings us to what I call Theseus IDs. This is a class of identifiers that you will see a number of different identifiers that meet these requirements. So let's talk about what is identity. I don't know how many of you have seen the Disney Pocahontas song. The thing I love about rivers is you can't step in the same river twice. A river is a thing that is in motion. The water that is in there is always new water coming in and always water moving out. The places where the banks are move, states that have used rivers to define the border between one state and another, the river keeps changing, and now we get into these debates. Okay, is it where the river was at the time the treaty was signed? If the river moves, does that change the borders of the state? These things are very ephemeral. And yet at the same time, you know what I mean. If I say this is the Mississippi River, or this is the Hudson River, or this is the Nile, no one says, oh, what do you mean by the Nile? We all know what the Nile is, even though this is a river that has changed its banks and overflowed and been redirected as people built dams. How is it that we were able to maintain a consistent identity of something that changed so much? Now, of course, Pocahontas wasn't the first person to bring up this issue. If you go and look at the ancient philosophers, there is a story they talk about, which is the ship of Theseus. Theseus set sail with his ship, and as one of the oars broke, the men went on shore and cut down a tree and sculpted a new oar and replaced that oar. When the mast broke, they replaced the mast. When the sails broke, they sewed new sails with crops that they were able to grow along the way. Eventually, if you replace every single part of the ship and then return, you're going to have a different experience for the people on the ship and for the people on the shore. The people on the ship changed one piece at a time, and it was always the ship. And when they got back, it was the same ship. But for the people on the shore, it felt like Theseus left in one ship and came back in another ship. It had different oars, different sails, different planks. So the philosopher asks, is this the same ship or is this not the same ship? Modern philosopher said, great, I love this thought experiment. Let's make it harder. Imagine that as the ship of Theseus is replacing its parts, you have one person who's replacing parts on the boat, and somebody else takes all of the boards and all of the broken oars and reassembles them and builds back the original ship. So now we have one ship of Theseus where we've changed it one board at a time, and one ship of Theseus that is made from all the discarded places of the first ship of Theseus. Is B or C actually the ship of Theseus at this point? And what they realized was it was really the witness. The thing that made it clear that the ship of Theseus was B and not C was the witness of the sailors who said, okay, when we started, we had the ship. We replaced one board. This board became not the ship of Theseus because we took it away, and the rest of the ship remains the ship. A good example of this is the internet. The original 6 computers that were on the internet, if you brought them all to the Computer History Museum and reattached them, would that be the internet? Or would the thing outside be the internet? And I would argue the thing outside would be the internet, because each time we added a new computer, we added a new computer to the internet. And each time we removed a computer, we removed a computer from the internet. So even if you put the removed computers back together, that's not really the internet anymore. So now we need to take a slight divergence into types of data. We want to have IDs. How do we assign identity to different people or even different types of data? So the first one to keep in mind is immutable data. There is some data that is simply a value. The string hello world, or the number 42. The number 42 will never be greater than it is right now. The number 42 will never be less than it is right now. The string hello world will never be a character longer, and the string hello world will never be a character shorter. Once you decide what your immutable data is, it is itself. And when we ask, what is the identity of 42? We just give it back to you. When someone says the identity function, they mean the function that gives you back the thing you gave it. We identify our immutable data by simply the data itself. 42 is 42. But let's say that the thing that we are trying to identify is a person. We can create some kind of birth certificate for the person and say, well, this is your name, and this is where your server lives, and here's all of your keys. And I could say, I'm going to identify this person not by their name, but by the fact that we want to have multiple different keys and multiple different ways to associate them and multiple facts about them. Maybe I want to have my name and some tags that says, hey, I went to Georgia Tech. I'm not just the person who's got this name. I've got this profile picture. I've got this face. I've got this Georgia Tech background. But we want to be able to update these docs over time. What if I change my name? What if I simply want to refer to this doc? It is inconvenient for me to say every time I want to refer to someone who is, say, the holder of some wallet, I'm going to give you the origin block of them creating their wallet and say, here's the thing that they put together that said, here's my name and here's my key and here's all my information. But we have ways to shorten that. So if I want to create a new ID, I can create what I call semi-immutable data, where I give some kind of name or some kind of pointer to that content. The example we usually see of this is hashes, or in the IPFS space, they use the CID as a way to identify the hash of the content. So if I say, hey, who is this person? Rather than giving you the doc, I can say, here is the SHA-256 of the doc that defines this particular user. Now, no matter how much information I put in their identity document, I can refer to everyone with the same fixed length identifier. I call it semi-immutable because there's only two states. Unlike the number 42, which is immutable, it just is 42. Now there's two answers. If I give you a hash, you could check and say, oh, hash 42. Yeah, this is the hash of 42. Or you can hash it and say, oh, no, that doesn't match. I don't know what this is a hash to. So there's only two states. There's this is the document that got hashed, and there's I don't know what the document is that got hashed. So it's either, oh, or it's the document. So it's not quite immutable. It has two states, semi-immutable. And that's how most of the DIDs work. So you're going to have some DID and then an identifier that says, hey, this is my certified content network. And here's my hash of random numbers that identify that document. So now when somebody says, here's my identity, and you go, oh, I don't recognize you, you can say, ah, here's my identity document. Now I can refer to that. So now we've made progress. We at least can have multiple different keys. We can have some information to try and identify that person. It's not just this blind key that we've got with something like a Bitcoin wallet. But what we want is more than that. We want sequential data. So if I have my document and say, hey, this is my original document and this is my key, and now I get a new phone. So I want to add an additional key. I need a way to say, hey, I was in state 1. Now I'm moving to state 2. And once I'm in state 2, I want to be able to say, oh, I'm getting rid of my old phone. I'm going to remove that key from my identity and give a new one. So now, like the ship of Theseus, I can remove a board and I can put in a new board. I can remove a key and put in a new key, but it's still going to remain the same identity because it's the same sequence of values. Excuse me. So how can we accomplish this? And the answer is we need some way to define a diff that says, okay, here was my previous state. Here's the identity string that I am updating, and then I have some kind of patch. So maybe I'm putting in a new account key, or I'm deleting an account key, or I'm changing something with the recovery, and then I'm going to sign that document. So if I've already added my phone as an authorized account key for my identity, and now I want to add my tablet, I can go on my phone and say, hey, I'm going to sign my tablet's public key being added to this. So I create a diff, I add the tablet's key, I sign it with some existing trusted key, and now I have an additional key that is present in my identity. This is a lot better than a Bitcoin wallet that's just pinned because we can now use better security. If I have a Bitcoin wallet, I don't necessarily want to tie that to a YubiKey because what if that YubiKey fails? I'm just locked out. I can't really use a system that won't give me back the keys. So we end up using these seed phrases and having to write them down and keep them safe. But if I had a system that said, hey, yeah, I can totally tie this to the TPM that is in my key and the TPM that is in my phone. Now I can say, okay, if it's either my YubiKey or my phone, then that's my identity. If I lose one of them, that's fine. I can use the other to add new things. So if I lost my phone, I would just go home, grab my key, put it into some computer and say, great, I'm going to add my new phone and I'm going to remove the old phone that I lost. Once I've removed all of the old keys, my identity still persists. I don't have to have some origin point that I keep forever. I can replace every key and still have it be my identity, just like in the Ship of Theseus, they're able to replace every board. So this seems like, okay, great, we're done. We now have sequential data. I can add things, I can move it around. Why is this something that people consider so complicated? And the answer is that not all data is nice, clean, linear sequences. What if I generate my identity and add a key to it, and then my phone says, delete my tablet, and my tablet says, delete my phone. And now I have this race condition. Okay, which one's the real ID? Is it the one where the phone removed the tablet or the one where the tablet removed the phone? I need to put these things in order in some way. So that's where we start getting to things like blockchains that you start to see is we need some kind of system that is a trusted, immutable ledger of ordered events. Oh, we have ways to do trusted immutable ledgers of ordered events. We could do this on something like a public ledger. But it's not the only thing that could do that. If I want to stand up my own server and say, this is my one-time ordering server, and for my identity, I'm going to say, this server is the blessed server to make choices for my identity, I could do that too. So I could have something as simple as, here's the single server that I've said is the ordering server, or here's the 5 servers that are doing Paxos that have to agree, 3 of the 5 of them, so that you can update my identity. Or I could say, here's my collection of servers doing some Byzantine fault-tolerant algorithm. Or I could go all the way to a public ledger like Bitcoin and say, yes, the way you decide who gets the event is whichever is in the block with the lowest block number, and for block number ties, whoever is highest up in the block itself for pinning. Make you pin the answer to a blockchain and pin it down. Now, this consortium has a certain amount of power. You have to trust it to do things like accept your changes, because I had some diff and I signed my diff, and then I tried to put my hash into some kind of consortium. If that consortium simply rejects it and is like, nope, I don't accept hashes from you, no transactions for you, you're not going to be able to update your ID. And if it decides to just forget about transactions, you can't prove that they have that transaction at one point in time. So you can sort of get locked out. But there is a limited amount of risk that comes from the fact that you've given the consortium, because the consortium only has one power. It has the power to assign an ordering to the events that you had. So if I had my origin doc of 1, and one of my keys says, great, I'm going to move the phone to the tablet, and the other one says, I'm going to move the tablet to the phone, then I'm going to diverge. So red becomes yellow and blue. Well, suddenly the yellow one made it into the consortium and became a blessed state. So it is truly the second state that my ID ever took. The blue one is rejected and says, no, no, you were not off the head. But that doesn't mean that the blue update is just in trouble. The blue update can now do a rebase. If you've ever used Git, you have these choices. You can try and do a merge, or you can do a rebase and say, hey, I'm going to go back to the head and put my thing in the front of the head. Either way, you're going to get a new node that is this merge node or rebase node that says, here's my multiple pasts, but one of the parents of this merged node is the thing that used to be the head. So the consortium can use this very simple algorithm. I only move forward in sequence. 1 can become 2. If 2's not the head, oh, you came off the wrong node. You have to either merge or rebase so that 3 is accepted because it is got 2 as a parent. And you have to have the current head as a parent of your commit if your commit is going to be accepted. So now we're back to having our sequence. So the thing to remember here is that the consortium is not the ID controller. You don't have to be worried that the consortium of people out there in the world is going to take your account away or steal your account. When I have a domain name, the consortium that is ICANN, they have the right to take it away from me. They can say, hey, Aaron, you registered Coca-Cola.com. Turns out somebody else has the trademark for Coca-Cola. We're going to take away Coca-Cola.com from you, and we're going to give it to the Coca-Cola company because they have a better claim to it. In a Theseus ID, you don't have that power. Once my ID is this hash of my original document, that cannot be assigned by anyone but me to someone else, because the only option the consortium has is to say, what are the updates I'm going to bless and give a sequence number, and what are the updates I'm not going to bless and not going to give a sequence number. They can't make up a new commit out of thin air and be like, yes, we are taking away all your keys and putting Coca-Cola's key there. So how do we get this consortium to do it? We add one more concept. So we had the diffs that were signed by the person who's updating the ID and by the account key that's in it. And we have ticks that are what is providing the temporal ordering for us, that is signed by something that can put them in order. Whether that tick key is just the key of the server that I've decided to trust to do this, Maybe I've decided I like someone like Google or LastPass to be my event ordering service, and I'm just going to go to their server and have them do the update because I trust them to be up. Maybe I'm going to use something like Ethereum or Bitcoin. And we have DIDs like did Ion that do just this and say, the only way that you can update your document is you have to be signed by a key that exists previously in the document, and then it has to go into the Bitcoin chain. So now we have this signature and we have the ticks to put everything in order. We've got our sequence. This gives us one more thing that we want to do, which is, what if I get my phone stolen? If I get my phone stolen, the person who stole my phone could remove my tablet and my laptop and my YubiKey and take away all of my rights to the devices. But fortunately for us, we have a timestamping service. So they can go to the tick and say, hey, I'm removing this. And we can say, no, I'm going to have a recovery key. I'm going to give special powers to my YubiKey that says, this is my recovery key. Even if my phone has started deleting all my other keys, this is still going to work. The advantage of a recovery key is now I don't get locked out. Someone stole my phone. They took my wallet. I go home, I say, no, they didn't actually take my wallet. I'm revoking everything. I'm canceling all of the transactions that haven't gone through yet. Now I've reclaimed my ID with the recovery key. But this has a cost, which is as long as I can have a recovery key, it doesn't matter that you started making changes. So when I added my phone and then I got a new phone, I could remove my old phone. But what do I do with these recovery keys? Because what good is removing a recovery key if it can just say, no, I'm the special recovery key. I'm going to go back. So we use the fact that we have timestamps now and say, if somebody is coming out and saying, I want to do a recovery, then only in the last 72 hours is that going to work. If more than 72 hours have gone by, then I'm not going to allow it. If less than 72 hours have gone by, then I am going to allow it. And now it becomes possible again to do things like sell an ID from one person to another. If I want to sell you my ID, I add your key, you remove all my keys and all my recovery keys. And as soon as I wait the window, all my recovery keys are now not valid anymore. And the transfer has been moved to you in a way that there's nothing I can do about it. I have given it away. I didn't contest it in the window, and now it's yours. So what happens if I miss my window? I get my phone stolen. My recovery key is at home. I'm not going to be home for my vacation for a week. I'm screwed. And the way to get around that is to allow the other keys to contest, to say, okay, the phone removed the tablet removed the phone. I'm going to take the both and say, I'm contesting. I'm in an inconsistent state. I'm locked. Wait for the recovery key. Now the recovery key can take as much time as they want to fix it, because even though the recovery key wasn't used to unlock the account within 72 hours, the actual account keys were used to lock the account. So now we've got our sequential data. I've got an identity. I can update my identity. I can use much stronger versions of keys because I can keep it in the TPM on my phone and say, you cannot extract the key from the TPM in my phone. It's not like some piece of paper that's got my passphrase on it that somebody can just be told and use somewhere else or possibly even guess. These are the keys that are in the TPM of my device. Even I can't ever get access to the private key. When I get a new device, I generate new keys. I add those keys to my identity. When I'm done with this device, I remove the device from it. So let's walk through an example. I start with A. This is my phone. I decide, great, I'm going to add my laptop. I'm going to use my laptop to add my tablet. Someday I get a new phone. And then I say, you know what, my new phone removes the old phone. And at the end of all of these transactions, I'm just going to have the laptop, the tablet, and the new phone able to access my identity. And the old phone I can give away. There's no fear in the fact that it's got a TPM in it that has a key that used to matter to me because it's gone. So even though the original keys are gone, every original board that we had has been replaced, in this case, just the key A, it's still the new thing that's the identity. Some new person can take that old phone and use that TPM and start using the key A as their own key. And that doesn't matter to you because the boards that have been reassembled do not make a ship. There's a few extra pieces you want here. So for example, if I go to the consortium and say, hey, what updates have happened? And it gives me back an empty tick and says, there are no updates that have happened. I've never heard anything about this key. Well, we're not actually as stuck as it seems, because if I show up to you and say, hey, I want to interact directly with you and I give you my ID, I can give you the document and you can hash that document and know that it's fair. And I can give you any diffs that have added keys to that thing. And I'm not worried about the race condition as long as the only thing I do is add. As long as I am just adding to the dictionary, there isn't going to be any conflicts. The only way there can be a conflict is if I'm trying to remove you and you're trying to remove me, one of us is going to use a power that we no longer have. And there's a whole study of which are the kinds of transactions that are confluent invariant, I believe is the term, that these things can be done without needing a strict ordering server. So merely by saying no keys have ever been removed because I have no ticks that I've signed for any kind of key removal, I can trust keys that have been added. So as long as you don't need to update it, you can get security. I see a lot of people who are like, no, I don't want to trust outside third parties. I'm just never going to lose my keys, and I'm trustworthy enough to never lose my keys. So I'm just going to use a public key as my identity. And the answer is fine. Even if you're that person, you're still better off using a Theseus ID, because when people go to the consortium, they're going to see no updates have happened, and your original key is going to be there, and you'll still have your key. And you still get all of the security that you thought you were going to get by using a key directly and managing the key yourself and just not losing it. But in the event that you do at some later point decide, wow, it's really stressful to manage my own keys, I'm terrified that I'm going to lose access to this account, at that later point, you can sign a diff and add a new key and give it to some escrow service. Like, you are in a position where you can escape from the fact that you've taken on the burden of managing your own keys. And with a Theseus ID, you're in a position where you can recover from having trusted somebody else. I may have given a recovery key to some third-party service and say, okay, I'm going to allow my Gmail account to recover my Bitcoin wallet, and I'm going to add a recovery key and store that in my Gmail drive. Well, if at a later point you go, oh, drat, that was a terrible idea. Google has access to everything in my G drive. I don't want them to have that key. Great, revoke the key. Wait the 72 hours, it's gone. It enables you to change your trust level to say, I want to manage my keys. I want to trust someone. I want to take things back. So this explains all the pieces in our origin doc. We've got some kind of name that is going to help to identify that it's actually me, a home server where you can go find me, my account keys, which I can add, recovery keys to help me get back in if one of the account keys has locked the account, consortium keys to put everything in order, and tags I just like to keep around because it makes it much easier to search for people's identity. We talked about the fact that you can transfer and sell IDs. We have some people who talk about soul-bound tokens. This is a token that should be tied to this person forever. It is incredibly difficult to tie something to a specific person. I think it makes much more sense to say, I'm going to tie this to an identity. I'm going to tie this token to some particular wallet and say it cannot be transferred to new wallets, but the wallets themselves will still be able to be sold. If I have an identity that I wish to transfer, oh, I'm going out of the country for a while and I want somebody else to have access to my accounts while I'm gone and manage those accounts for me, it is good for me to be able to transfer control to someone, and when I get back, for them to transfer control back to me. And this ability to put keys and remove keys enables you to both delegate power and straight up sell it. Recovery keys let you get back in. I want to have a finite amount of time that a recovery key can work, but as long as somebody has locked the account within that time, we want to have the ability to recover. And we want to use device keys because, frankly, it is much more secure to authenticate yourself with something like a YubiKey than it is to authenticate yourself by typing in a username and password that you have to remember, or more likely you're going to have to store in some key management service. I have lots of devices that I want to authenticate. I actually trust Gmail to say, I want this person to be able to log in if they have my laptop or my phone or my tablet or my YubiKey, rather than just saying, oh, anyone who's got my username and password anywhere in the world. That said, people like passwords. You can use passwords. If I store a salt in the document and say, here's how I'm going to do my public key. I'm going to make a username and I'm going to make a password. And when I go to log in, I'm going to put in my ID and I'm going to pull down the salt and I'm going to give my username and password and I'm going to use my username and password and that public salt and I'm going to mix them together and I'm going to derive a new key and I'm going to use that key. Any computer I put my password into, I will be able to derive that. But this is also better than the passwords we have in most systems. What if a husband and wife want to share an account with something? Well, I can generate a password for me. My wife can generate a password for her. And now we both have those passwords essentially acting in the same way we would have two different devices that could access the account. And at some point, that could be switched and removed. Maybe I want to add somebody else to have access to my account. I pick a random string, I send them that password, they have access for a while, and then when the time has passed, I can remove them. So this doesn't actually break the login flows that we already have. Any company that has been using username and password already and wants to switch to a kind of Theseus ID could totally transfer their users over to this Theseus ID and leave the user experience the same of you log in with a username and password. Granted, they better make sure that they add a recovery key to that so that they can do the recovery tasks. But it also gives the user the option. They could say, hey, maybe you want to use this service and we'll generate an ID for you. And if at some future point you decide, you know what, I want to turn off password recovery, they could say, sure, we're going to delete our recovery key. And 72 hours later, there's nothing we can do to get you back in your account because you asked for it. So what are the states we can be in? We have an originally created origin doc. I can go ahead and start using this, give you the ID, trade back and forth, and it doesn't matter that it's not registered anywhere because it's append only. We can submit it to the consortium, and now other people can find my ID publicly. If they go ask the consortium and say, hey, do you have a document for this ID? They can pull back my document and use that as a service discovery to find my home server so they can get my content if you want to use it as like a domain name in the way you would use, say, a .eth name. We can have diffs that are created that are append only. I have a set of keys and I added one more key, so I have one more trusted device that can take actions, as long as the chain of keys is not removed by the stuff that has already been blessed as being in the sequence. We have a consortium that can bless things as final. Once the timestamp comes down and the consortium says, this is the third version of the key, that will always be the third version of the key. There may be a fourth version of the key, but everything from the third version back is finalized and is not going to change. So we can cache that anywhere. If I say, hey, in order for people to log into my service, I'm going to pull their identity, and then I'm going to allow them to be logged in for, say, 24 hours using those keys. And at the end of 24 hours, I'm going to go hit the consortium again and say, has this changed? Then I could do that. And I could set up callbacks and say, hey, I'm going to cache this for 24 hours of trust. But by the way, when I ping the consortium, hey, if this person ever updates their identity, send me the new doc. I'm going to subscribe for the next 24 hours. So you can still have fast logouts even as you are caching this content if the consortium is willing to give you push notifications for updates. We have a locked state. When I have two keys that each think that they should be the rightful key and they can test each other, we can simply lock the account and hopefully someone will come by with the recovery key eventually to save it. We have ticks that are issued by the consortium and we can actually transfer things. And because you can update documents, you could even transfer the consortium. The consortium key is just another field in the document. So if I say, hey, I've been using the Google servers as my consortium for timestamping for a long time, so now I would like to move to using Bitcoin, there's nothing to stop me from saying, hey, the field that I'm updating right now is the consortium, and I signed the thing, and it's now updated in my diff. And now when I try to send a new thing to Google, it's going to say, I'm sorry, I can't give you the 17th. I can't update the 17th version because the 16th version assigned the consortium to someone else. You need to go talk to that person. Be careful with that so you don't break your keys. And there's three classes of key holder. We have the account keys. They can make changes to your identity. We have the consortium key holder. The only thing they can do is put events in order. So the worst thing they can do to you is ignore you and say, I'm not going to let you put in any more changes to your identity. But all of the changes that are already there and are already signed by the consortium and can't be taken back. So the worst thing they can do for you is stop updating. And you have recovery key holders who the only thing they can do is unlock your account. And if you put those keys in the recovery key and you don't put them in the account keys, then you can give them to a friend and say, you know what? Maybe I totally trust my brother to help me get into my accounts in the event that I get locked out, but I don't want him to be able to just reset my password at any time and start pranking me. Well, if I have him as a recovery key holder, he can't do anything until one of my account keys says, hey, I'm contesting this change, put it into a locked state. So he's not going to just mess with me until I say, oh, now I'm in contested space and now he can save me. Grow only doesn't need you to do with the consortium. Removing keys does need you to deal with the consortium. It is important to remember that there are some transactions that can be done without any consensus, and adding keys to a set is something you can do without consensus. And that set can be a grow forever set, but adding and removing keys cannot, because you get these race conditions of, I added a key, you removed me, which one of these is valid? So our final answer when we get back to our ship of Theseus is, I think the answer is B. Each time we replaced a board in the ship of Theseus, the ship remained the ship and the board became the board, because the vast majority of the ship was on one side. Now, for a ship, that's very fuzzy. Which side is more ship-like? You know, if you imagine the ship being divided perfectly in half, you now have 0 ships. You don't have the ship of Theseus, you just have 2 broken apart halves. In a similar way, we can do this very formally and say, the thing that is going to be our update is some consensus algorithm. But we don't have to go that far with our Theseus IDs. We just say, look, any device can sign a new thing. We have a consensus group. That is the consortium that gives us our identity. B remains the ship. And C, while it is a valid ship, is no longer the ship of Theseus. It is a new ID that was generated with this origin block of the first board and then just had every board added to it. And we have a nice path. I start with some name, did, whatever my method is, and a simple hash. The hash from the did string will validate the origin doc. The origin doc gives me a key that I can use to validate the diffs. Diffs validate more and more diffs, can be turned into a current doc. And now I have the keys that I can use to authenticate you. So from there, you're off to the races. This is the same IDs that can be used in the way you use OpenID, log into Google, go to different sites, signing email, signing software. Like, once we have keys, that is the way we do identity on the entire internet. I can get new devices, I can still use passwords, I can recover IDs, and I can even sell IDs to other people. We have all of these features that we demand of our accounts, and we have it done well. The original thing I was building with this was a certified content network. I imagined that these IDs would be the heart of a new URL scheme where you say, hey, here's my hash, and then I've got some path, and you know that that record is in fact from me because it's in a Merkle tree that is my file system, and I sign the thing. But there's nothing that limits you to say that this ID is only going to be used for certifying repositories in a content-centric way. Lastly, I want to remind people about the trade-offs with IDs. Fundamentally, there are 3 different kinds of IDs, and it is because of the CAP theorem. Anytime you're building a distributed system, you have to choose 2 of consistency, availability, and partition tolerance. If I want something that is available and consistent, anyone can generate an ID at any time, and no 2 people will ever have the same ID, I have to use some kind of randomness. I can generate a 256-bit key, and you can generate a 256-bit key, and some alien that SETI has not found yet can generate a 256-bit key, and none of us will ever have the same key because 256 bits is just a lot of entropy, and the birthday problem isn't going to allow us to have the same keys. So you can generate keys locally, and they're perfectly exclusive. If you want to have something that is available and partition tolerant, you can just use tags. If I say, hey, this tweet is a Black Lives Matter tweet, then I just put the tag on it. And I can do that locally. It's always available to me. People can do it in different places. It's not a problem. You get to pick exactly what you want your thing to be. It's not like a public key where you get some random sequence of numbers, but it's not exclusive. I can use a hashtag. You can use a hashtag. Anyone can use a hashtag. We get the locality we want, and we get to choose our ID, but we can't exclude other people from using the ID. And then you have the IDs that we are all most familiar with, addresses. They are exclusive and they're chosen, but they're not local. If I want to get a Gmail address, I have to go ask Gmail, hey, Mr. Gmail, can I have permission to have this name? Is this name already taken? I can't just generate that ID for myself in a self-sovereign way. If I want to have a .e, I'm going to have to go check some Ethereum contract and say, hey, Ethereum contract and Ethereum network more generally, can I register this name? And it's either going to say yes or no. I can't generate that locally. I require someone else to do it. So with a Theseus ID, we get this balance. I can generate my names locally, and it is exclusive to me, and I get some help with the tags because, yes, fundamentally, this ID is a fingerprint. It's did CCN and then some random numbers, but I can search for it in a reasonable way because I have allowed display names and tags and other things that make it feel a little bit more human readable. So once I have the document, I can say, hey, bring up all my friends who consider themselves to have the first name Bob. And that's going to be relatively small numbers and is going to make the search work a little bit better. So I think this gives us a nice balance of both the fingerprint property and a little bit of the tags. And with that, I'd like to open the floor to questions. Does this fit with the way you've been thinking about identity, either for local systems, the way we do Web 2 now, or in the Web 3 more blockchain-y way? Or has this been entirely confusing and I lost the whole audience? Either way, I would like to hear feedback. Thank you very much.
Woo! Thanks so much, Aaron. That was super interesting. I really like the idea that you have of kind of like connecting different devices or fingerprints together using like the sort of Merkle tree structure. Yeah, I don't know. I don't really have any questions. I'm just trying to process it. Anyone else?
Yes, you mentioned that part of the security relies on like the inability of like the average person to access the TPM. Right, but like we all know that the TPM isn't tamper proof, it's only tamper resistant. Sure, I probably couldn't get into it, but like the CIA definitely could, or someone with enough.
There's
like,
definitely people who are like, this is a tamper proof module, and I'm like, nope, this is a trusted platform module. And note, I didn't say trustworthy platform module, I said trusted platform module.
Sure, so I'm just curious, like what kind of attacks could somebody do on this if they did have access to the TPM?
Yeah, so I start with this argument of I would rather use something like this than use a password. And at first glance, that seems kind of silly because if you've got my YubiKey, like anyone with a finger that's got blood in it has enough capacitance that they can hit the button and it's going to authenticate them. There's no like password on my YubiKey. Just having my YubiKey means you get access to my account. So that one's relatively easy to use, even though the key is fairly difficult to extract. But most of the people who are trying to attack your account are not within 12 feet of you. So my general attitude is I would rather have keys in TPMs at base because that is just much harder for most of the people who are on the internet to attack. Yeah, it's true that if someone managed to get a hold of your phone and freeze it in some kind of liquid nitrogen and open the thing up and read out the values before the capacitance could degrade, yeah, they can get your key out of your YubiKey device. But they're not going to get everybody's key out of everybody's YubiKey device. We don't want is these sort of mass scale brute forcing, and we don't want what we have today on Twitter and Google, which is people that just try the most common 10 million passwords on all kinds of accounts. No matter who you are, occasionally you get those emails. It's like, hey, somebody just tried to log into your account with the wrong password 10 times. And you're like, okay, what do you want me to do about that? I'm not going to change my password. It's someone random guessing. So Is it perfect? Certainly not. There are ways to get things out. And there are certainly people who will, even in a system like this, decide that they want to use username and password and derive their keys from that. But I think it is an improvement over the current state, because most of the successful phishing attacks that I've seen, at least in the corporate world, start with someone saying, hey, I need your password for X. And I don't want people to give away, I need your password for X.
Yeah, I definitely agree. I also had a question. Could you recommend any like production ready solutions that already exist for this, or is this kind of like more a theoretical thing?
So there's sort of two answers there. The first is all the way back where I started. Look at the did spec registry. There are lots of DIDs that basically look like this. The one that is probably furthest along right now is did ion, which uses the Bitcoin chain as the consortium. It's also really annoying to use did ion, because anytime you want to do any kind of change to your ID, you have to wait for 2 Bitcoin blocks to land before you see your update, which is annoying and slow. That said, Varus has one that's popular. Ceramic has one that's popular out of 3Box Labs. There are a few people who are competing. I suspect that the did that is going to become the popular did that everybody uses is going to very much follow this Theseus ID model, and I don't think it has been built yet. But my guess is the really popular did that ends up being the one that takes over the world is going to look very much like this model, even if it is not yet created. I don't know if that's helpful or not.
No, that makes a lot of sense.
I should say the reason that did ion is becoming popular is that Microsoft runs a series of servers that will do a lot of the did ion work for you. So you can hit a Microsoft API and just be like, post, make a did ion for me. And they'll message you back in 30 minutes when it's like, hey, 2 Bitcoin blocks have landed. Your ID now exists. And people just sort of piggyback off of Microsoft. And it's like, great, you're using Bitcoin as your totally trusted decentralized consortium. But then you send all your traffic to Microsoft so they can do whatever they want with it. Fine. I mean, to be fair, I would be fine with just using a Microsoft server as my consortium, because I think they're trusted enough to put timestamps on things. They're not actually taking over IDs. So I shouldn't give people grief for using the Microsoft server, because I would use the Microsoft server without Bitcoin behind it personally. All right, any other questions? Oh, feedback on the name. Do people think Theseus ID is a stupid name for this idea or a reasonable analogy? This is my first time giving the talk, and I am debating changing the name before the next one.
I like the name. At first I didn't know what you're talking about because I hadn't heard of like the Theseus thing, but it seems pretty adequate.
Yes, it does force you to go through this like, wait, what is the ship of Theseus? And we can debate with people, okay, which squares would you click on this CAPTCHA?
Cool. Well, if no one has any other questions, I think we can wrap it up.
Yeah, and I'm happy to take more questions after we stop the video, which sometimes inspires people.
Let me stop this.